Hi everyone, I'm Susie.
Hi, I'm Bobby, and we are Team Bless You. And our project is to able to achieve a sneeze detection.
Yes, so as Bobby said, our project goal is to detect human sneezes using Arduino 33 BLE Sense board and the microphone on it. And when a sneeze is detected, there's going to be a bless you message sent from Arduino to the computer. Our system is supposed to be accurate, reliable, and robust by the end of this quarter, and that's we always want to achieve. So for the collection part, we found sneeze samples from Google and YouTube, and we recorded them using Arduino. The microphone sampling frequency was set to 16 kHz, and the data sampling frequency is set to 200 hertz. So the data sampling frequency, when we try to find it, we set to be 200. That's because the nature of the sneezes, it was short, so we had to make sure we capture enough data points during one sneeze, but at the same time, we don't want to capture too much data point like before and after the sneeze. For data processing part, first we calibrated the microphone to get rid of the background noises and unwanted offset, and then we perform FFT on our data to convert it from time domain to frequency domain, and so it's better for our feature extraction since we basically detect our sneeze on frequency band. And lastly, before we fed the data into classifier, we applied IR filter. And for the machine learning part, we have tried several classifiers such as SVM decision tree, logistic regression, and we found out that random forest came with the highest classification accuracy. And lastly, our communication was using BLE protocol Bluetooth Low Energy.
So, for our current status, we collected around like 200 data points for sneezes, and we also recorded around 100 data points for like the background noises, including like noises that has like a similar pattern to like sneezes, such as like tapping the table and then snapping fingers and also clapping, since those noises has like also a spike on the frequency domain, so it will be we will need to be able to distinguish those noises compared to the sneezes. And for the machine learning aspect for our current status, we like Susie mentioned that we achieved around 92% accuracy when using the random forest algorithm, and for compared to other algorithms like SVM and also like logistic regressions, we the accuracy is around 50% to 60%. That's why we kind of settle with random forest algorithm right now. And for the accuracy on uh, actual sneeze detection on Arduino, we are able to stably detect like the background noises and achieve around 80% accuracy when we actually classifying the sneezes. And for our communication, we are able to receive signal once from our Arduino, and the reason will be further discussed on the future step part. Yeah. So for our future step, we for data collection, we will need to try a different like threshold and also sampling frequency, since that right now we are using uh, the frequency magnitude of like 400 and also the sample frequency of like 200 hertz. So maybe there's a better combination of those two variables that will result more accurate sampling sample. and to capture their sneezes. And also, we will need to collect a larger data set for both sneezes and background noises. And for the machine learning aspect, like we said, we the current best option for us is the random forest algorithm, but we and but neural network is like one of the most popular algorithm out there for machine learning. So our next step will be trying to implement the tiny ML neural network to train our classifier. And for the communication aspect, since we need to figure it out a way to clean up the receiving buffer on the computer side. Uh, the problem we are facing right now is that like after the Arduino sends rec- the data to the computer side, it the buffer on the computer side will not clean up. It will keep repeating the previous results and the signal. So we need to figure a way to like clean up that receiving buffer on the computer side to achieve a stable communication between Arduino and our computer. So that would be it for our presentation for today.
Thank you.
Thank you.